take a look at something called a compound inequality and how we can go about solving these. Okay. So a compound inequality is simply two or more inequalities. Putting together two or more inequalities. We combine these inequalities using the word and or, okay, when we're combining these. So we're going to talk about these two different types of inequalities and what might be different between them. So the first type we have is an and inequality. And we're going to be dealing with just combining two inequalities for this purpose. So both parts of the inequality in an and inequality must be true for the entire statement to be true. So if we look at this example under here, this says x is greater than 4 and x is less than 8. So that means we're looking for a number that satisfies both of those criteria. So values like 5, it's larger than 4, but less than 8. 6.7, larger than 4, but less than 8. Both of those are examples of something that might satisfy this and inequality. Okay, so sometimes we call this an intersection of two sets of numbers. And we'll see in a minute here why we call this an intersection. So if we graph these two inequalities separately, so I'm going to graph x is greater than 4 right here. And then we're going to graph where x is less than 8. So that would be graphed right here. The values that satisfy both of these inequalities are in the intersection of these two graphs, right? Or we could say the overlap of these two graphs, right? So we would still have an open circle at 4 because 4 doesn't satisfy both of those. Open circle at 8, and then all those values in between satisfy. So there's our 5 and our 6.7 and a bunch of other numbers that work for both of those inequalities. So if we were graphing the intersection or the and inequality, we would just graph the part that works for both. So open circle at 4 all the way up to an open circle at 8. So we can write this inequality in two different ways. The first way we can write it as we had it above is just using the word and. So x is greater than 4 and x is less than 8, implying that we have to have both of them. So whenever you think of an and inequality, you want to think of asking someone a question or asking them for some item. So if I ask you, can I have a pencil and a piece of paper? I'm expecting you to give me both of those things. So when you have an and inequality, you want to make sure you're satisfying both. Now, the second way we could write this is if we look at the image, we are looking at numbers that are in between two values, right? We're in between 4 and 8 here. So we can write this compound inequality as x is between 4 and 8, and then we need some inequality symbols in there. So if we look at the inequality symbol for x is greater than 4, we can see that the open part of the inequality is towards the x and the pointy side of the inequality is towards the 4. We want to keep that consistent. And so that's how we're going to bring it down here. Open towards the x, pointy towards the 4. And then x is less than 8. That just comes down just as it is because we are still reading that from left to right. The reason we had to flip the other one is because we're kind of reading it backwards. Whereas before we read x is greater than 4, we can read that backwards as 4 is less than x. But we do have to switch that inequality. So that's our and. So let's take a look at our or. So an or compound inequality works by saying either of the inequalities could be true. Okay, so this is like if you asked someone for a pen or a pencil, right? You'd be okay if they gave you either one. You're not expecting both, but you also probably wouldn't be upset if they gave you both. Like that would be fine. You would still have what you requested. So an or is where either part of the inequality, compound inequality, could be true, or both. It's fine, all of the above. So this says x is less than or equal to -2, or x is greater than 3. So a solution is any number that satisfies either inequality. So we can think of some numbers that satisfy the left one, such as -5 or maybe -10/3. Those all satisfy that left inequality. And we can think of some numbers that satisfy the right inequality. So 10 or 20. Any of those are going to be a solution. So this is often called a union of two sets of numbers. We're taking two kind of distinct sets of numbers and we're saying that we're going to combine all of those answers into a union. So if we graph these, x is less than or equal to -2, close circle because we have that or equals to, x is greater than or equal to 3. All right, the or is telling us that I can select a number from any of those shaded regions and it'll be a solution to the compound inequality. Okay. Unlike an and, we only have one way to write an or inequality, and it is as we have it written above here using the word or in between the two inequalities. So let's take a look at an example solving some of these inequalities. So when we're solving an and compound inequality, if it's written with an and, then all we want to do is look at them separately. So I'm almost going to just ignore completely the left-hand side or the right-hand side for a moment. So don't cross that off on your paper because I'm going to be erasing that in a moment. I'm going to ignore that right-hand side and I'm just going to solve the left. So we're going to divide both sides by 2 and we're going to get x is less than 6. Okay, then I'm going to solve this right-hand side. So now I'm going to ignore the left and I'm going to solve the rightmost one. So I'm going to subtract 2 from both sides. Get 3x is greater than 3. Divide both sides by 3. X is greater than 1. So now I have two inequalities, but this is still an and. So we need to write it as an and inequality. X is less than 6 and x is greater than 1. And we're also going to sketch a quick graph. So when we're sketching a quick graph, all we need to do is put the two numbers on the graph in the appropriate order or the number line, and then sketch what that compound inequality would look like. And remember, we can describe an and as between. So we could reread this as x is between 1 and 6, and we would have open circles because they're not equal to. All right, well, what if it's written the other way? Okay. Well, in this case, we're just going to think about this as having three sides to an inequality, right? We can see side 1 is less than side 2 is less than side 3. And what we're going to do is we're going to solve this by doing the same thing to all three sides of an inequality. One way to help remember to do this is to put dashed lines in between your inequalities to make sure that you're making those very distinct sides, right? And make sure that you have something in each column every time you do an operation. So first thing to solve, just get rid of one side for a moment and look at that inequality as if it was a normal inequality. What would you do first? Well, we would subtract 4. But now we have this third side that we also need to subtract 4 from. Okay. Well, -8 minus 4 is -12. Which is less than or equal to, we got 0 there, so 2x, which is less than or equal to 6. So again, go ahead and ignore that left-hand side for a moment. What would we do if we just had that normal kind of middle and right? Well, we divide by 2. So we just need to do that to the third side. So we get -6 is less than or equal to x, because that's 1 right there, 2 over 2, which is less than or equal to 3. So if we were to sketch that, we put -6 and 3 there. We'd have closed circles, and this is an and, so it's the in between. So we'd shade in between. An or is very similar to an and, where we're just going to solve each one separately. So I'm just going to solve the leftmost and then the rightmost, and then we'll write it in the end as an or inequality. So adding 5 to both sides, get 3x is less than 15. Dividing by 3, you get x is less than 5. Now, if we do this nicely and our inequalities line up, we don't have to rewrite, but we do want to make sure that our answer is neat at the end. So we can say or, and now solve the other one. So subtract 1 from both sides. Negative 2x is less than negative 18. Divide both sides by negative 2. Now this is where we need to be very careful, because remember, in an inequality, when we're dividing or multiplying by a negative value, you need to switch your inequality symbol. So we're going to get x is greater than 9. And we can sketch that to make sure it makes sense and looks like an or inequality. So here we have 5 and 9. So we have an open circle at 9, greater than, going to the right. Open circle at 5, less than, going to the left. So it does look correct there. Looks like an or. If we graphed it and looks like something different, we might want to double check our work. Let's take a look at a couple more. I'm going to just do a couple that are a little bit different. So I'm going to look mainly here at 2 and at 4. Okay. So let's take a look at 2 if we want to solve this. So we're just going to work, this is an or, right? So we're just going to work with the left and then work with the right. So we can add 3 to both sides. Add 3 to both sides. You get 1/2 x is less than or equal to a negative 2. You can divide by 1/2, or as I prefer, multiply both sides by the reciprocal. We get that x is less than or equal to 4. Now, or we need to do our second one. So if for this one, I would again multiply both sides by the reciprocal or divide by negative 2/3. We're going to get that x is, now we're multiplied by a negative, so we have to flip our sign, greater than negative 6. Oh, excuse me, that should be a positive 6, because a negative times a negative is a positive. All right, we're just going to sketch this graph. So we have x is less than or equal to 4. So closed circle at 4, and then shading in the less than direction. So for the numbers that are less than 4, x is greater than 6. So open circle at 6, and the numbers greater than 6 are to the right. All right, next example. Number 4. This is an and. It's written as a single kind of continuous inequality rather than using the word. So we're going to just solve all 3 sides of this inequality. Solve using all 3 sides. First thing I'm going to do is get rid of that denominator by multiplying all 3 sides by 2. Okay, we're going to get negative 22 is less than 3x plus 2, which is less than 20. We'll subtract 2 from all 3 sides. So remember, we're working with 3 sides now. Negative 24 is less than 3x, which is less than 18. Divide all 3 sides by 3. And we get that negative 8 is less than x, which is less than 6. So we can read that as x is between negative 8 and 6. We need an open circle at negative 8, an open circle at 6, and then this inequality covers all the numbers in between.